Welcome to Embedded World 2022. I'm here with Steve Douglas, Corporate VP of Research and Development of Lattice Semiconductor. Steve, can you just tell us something about the Lattice vision for the future?
Absolutely. Lattice is focused on a technology called FPGAs. These are a programmable hardware technology that allows customers to not only design their hardware customized for their particular application, but it enables them to reprogram it over time, and they can make modifications to their design with time. They're very power efficient, and they come in very small form factors. They're perfect for edge applications such as industrial, automation types of applications. We're in automotive electronics. We're also found in laptops and servers. Yes, we're in virtually every marketplace there is, because the flexibility of programmable hardware really has benefits across all markets, and the need for FPGAs continues to grow with time, because technology is advancing so rapidly, especially the advent of things like artificial intelligence. We're adding more smarts to all the equipment that's out there, and those algorithms are changing so rapidly. So it's like as soon as you build your hardware, it becomes obsolete by the day you have it ready to ship. And so an FPGA allows customers to do an initial design and then refresh it and update it and keep pace with all those advances in technology.
Okay, so that sounds good. Now, I think it seems that FPGAs have been considered quite niche up to now. Can you see them becoming more mainstream, therefore?
Yes. I think FPGAs for quite a while have really been targeted on certain types of applications, and a lot of the market was really focused on large FPGAs, high-end FPGAs. What are the biggest, fastest FPGAs we can make? Because they were focused on what I call heavy iron communications, wired and wireless comms infrastructure, and there was also a lot of focus on data center over the last few years. You know, there's a lot of compute challenges in the cloud, and so FPGAs have been used as a hardware accelerator. Those chips are very large, they're very high performance, but they burn a lot of power, and they're very expensive. So they're limited in the applications that they can serve. But with Lattice technology, like our now industry-leading power-efficient Nexus product family, we are building FPGAs that are very power-efficient for a very wide range, mainstream set of applications. In fact, we're designed into client laptops, and yes, we're used as a low power mode device. We stay on all the time, and we do human presence detection algorithms. So if a user is looking away from their screen, or they've walked away, it allows the laptop to go into a power down mode and save a lot of power. And then when somebody walks up or they look at the screen again, it powers back on and the processor comes up to speed. We burn a very small amount of power to do that, like tens of milliwatts, but we have the AI algorithms running on our FPGA to do that. If those were run on the CPU of the processor, it would burn a lot more power and would run the battery life down on those devices. So by using just a very small FPGA in the system, it allows the laptop battery life to be extended by like 50%. So that's just one example of how FPGA technology can be used in a very mainstream application, technology that we all use today.
And therefore becoming a lot more useful with sensors and other type of products.
Yes.
Working with them to achieve that.
Absolutely. And in fact, as people build more and more devices out on the edge, they're equipping them with more and more sensors. Temperature sensors, thermal sensors. There's a lot of video sensors out there too. Embedded vision is everywhere. Everyone's got a camera, and it's generating all kinds of data that needs to be processed. Now, when edge devices first started generating all this data with sensors, they'd look at it a little bit, do some processing, and then send it off to the cloud. And all the processing will be done off in the cloud. But now, there's so much real-time processing of the data that has to happen for these AI algorithms, that computation has to be done at the device. And so having FPGAs there to implement those algorithms locally gives a lot of flexibility for customers who are building systems with a lot more sensors.
So fortunately, we don't have any of those in our camera, so...
Yet.
Yet. So I'd like to thank you very much for giving us that overview. Really do appreciate it. It'd be good meeting you.
My pleasure, Lorna, and enjoy the conference here and look forward to seeing you around.